Hello and good morning, everyone. My name is Sebastian. I'm the novice prospect, and we're back to programming, I want to call it. But it's also for sciencing and just shits and giggles and what have you not. Before we dive into what I was actually trying to finish off yesterday, I want to quickly show what I've managed to put together in C++. Yeah, you had Pevins.
Pregnancies.
Yeah, it wasn't what you said. Last name.
I was still right.
Yeah, you had everything else. Spot on.
I couldn't show the next
Yeah. I know. So let me go into the build directory. Let me go and rmrf everything. Yes, all the things. Delete, kill, exterminate. We probably still have a bunch of dot files, so dot star I think should do it. No, not ls. Sorry, rmrf. Kill all the things, yeah? Better. Right. We're gonna CMake our build quickly here from yesterday. Basically, I have it working. So if I now go say hill. Oh wait, we've only got the build result at the moment. I still need to make the thing. So we go Ninja. Cool, and I should now have a hello raylib in here, and we have a game window. It draws on the screen. I can increase the target FPS to make the bottom one move faster or slower. And what's actually happening is that the top circle is essentially holding always the same timing. And it becomes more obvious actually when we slow right down, right? And you see now the red circle actually overtaking the, I'm going to call it blue circle. Yeah, it's blue. Because it wants to move a fixed amount of time for every frame. Okay, whereas the blue circle is actually limited in its speed by the frame time, and you can see in the output window what our target time per frame is as we increase our target time. And now you see the blue circle sort of just running away with it because it has more frames available to move. Essentially in the same time, whereas this one always moves the same amount between each frame, so it now is going to slow down more and more. What becomes interesting is if I go the other, actually let me reset and then, oh, it doesn't reset the target. I should have implemented that too, but it's fine. By the way, the bouncing works, and I've even accounted for the size of the radii, because that was actually off in my initial thing. But if I now go really right down to basically targeting for 0 frames, we now go into unlimited frames, and you can see the blue wheel just really taking off because we're rendering at thousands of frames per second. No, not quite, hundreds. No, I see 1,000 appearing every so often. But and I have also then played a bit more and done the exit dialogue. And do you want to exit? Yes, and it exits with 69. Because we need to have some nice output.
Why 69?
Yes, better than 0.
Why 69?
Yeah, but why not? But so yeah, this lives on the Codebug repo. Speaking of which, let me go and link in quickly and pin today's, what you call it, repo. Follow along. So we're going to go back to our mono game project. That's the point, right? Or the hope, anyways. And there is one pin, and let me do the same along here. Something like so, and I click the button to say pin the message, yeah? Das ist gut, ja. Okay, cool. Right, let's get to it. Where were we? We were building a slime snake thing, right? I remember that much. So let's jump out of Hello Raylib and go into learning. No, oh yeah. learning mono game, and we shall tell Visual Studio Code, arise, my son. Yes, close, thank you. And we were working right there on the slime segments. Cool. So let's try and find. No, I think we were actually working on the actual slime already. Yeah. Because we had already created a bunch of properties here. We've got the movement time, and right, they're doing the S because it's a static. I guess I can live with that. But then I would probably need to do this in quite a few places. We'll talk. We'll look at that later. Anyways, we want now a new event handler. So let's just say this is a public event. Yeah, event handler, type event handler. Called body collision. And we go event that's raised if it is detected that the head segment of the slime has collided with the body segment. Event triggered upon body getting head. Right? When the body's getting hit, then bad things happened. What?
Messy.
It's messy too, yes. Then we need a little constructorino. So I go and see to that beach. And it'll take in an animated sprite. Sure. We can do that. Animated sprite, we'll just call it a sprite. Sure. What are we doing with it? We're just assigning our actual property from that initialization variable, and off we go. Why no? Why you no make? Why you no make comment? Yeah, that. Thank you. You're confusing me there for a second. Construct the slime snake. Well, no, yeah, well, maybe we can call it a snake. Maybe that is a bit too impinging on Nokia's copyright. I mean,
Not really, because you put slime in front of it.
yeah. Still, let's not be too cheeky. I'm cheeky enough as it is.
Slime slither.
Yeah. Holding the slime texture. Well, it's not a texture, it's a sprite. So the sprite is a part of that texture. Well, comes from a texture atlas. Whatever. No need to get bogged down in technicalities. Shushed you. You're not helping.
So I never said it was not.
Oh, that's true enough. Initialize.
That is completely at my league.
I know. Vector to start position. And we're making a float which is called stride. It's basically the amount of movement we want to have, from what I understand. And then we basically say segments as a new list. Just a new. I think this should actually just work as initialization. Can even be more simplified. How? That. God. Okay. Yeah. I think I can. No, I can't read that. That means nothing to me. The new keyword at the very least tells me, okay, okay, there's something here. Because then I can always derive that the fact that segments itself, it's a list of slime segment. Well, that's easy enough, but I like the new keyword there still. Let's not oversimplify. and the stride is essentially coming directly from the variable that we're passing in. We then create the initial head of the slime chain, right? We like getting head, so this is a new slime segment. uh, it's going to be possibly outrageous, but it's fine. It's fine.
Possibly. It will be.
We're gonna have head at. We're gonna have head at starting position. Apparently so. We're gonna have head at starting position. Why did I? Yeah, no, I just called the start position instead of starting position. It's just less typing. And we're gonna head to with our head that we're getting apparently at somewhere. I don't see that being a thing I can do, but let's just say I can, and say starting position, start position. Start position. Oh god, I hate this so much. I definitely named this wrong because there should be a capital P in there. And well, let's just follow the convention so we're not confusing ourselves. Is plus new vector 2 of stride taken actually the property stride and 0. Okay. Trying to understand what we're doing there. So let's go into the slime segmentation definition. It has an at. Did I forget a 2? Yes, I did. Yes, I did. There's another vector 2 that we're needing here. That's why that is failing. The position this slime segment is at after the movement cycle, right? No, the position this the position this slime segment should move to. Yeah. Move to during the next movement cycle. Of 2. That makes more sense than that property can actually get used inside the slime. Yes. So we're just setting 2 vector 2s essentially here. We're just saying, okay, we're here and we want to get there. Right. It's basically, this is just talking in graphics really realistically. Right, this is for that. Okay. And then we're gonna say head direction. I don't care what direction the head is, but as long as I'm getting it right. Yeah.
Make sure they can still breathe.
Well, a little breathing would be possibly helpful, but we'll talk later about that. Getting worse and worse here. It's fine. Segments add. Add some head. We're gonna add some head. Always.
There's no breath.
I'll let you come up every.
If there's no breath, we'd be fucked.
I'll let you come up every so often. Oh,
Could be that sort of day.
it's gonna be that sort of day. It's fine. It almost feels like every day is that sort of day at the moment. Yeah, the equals time span. Now we're gonna do some input handling. Sure. Everything's still grooving along, yes. I think. Yes. Everything seems to be moving and grooving and be happy, be healthy, or something like that. Anyways,
Blah, 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 say.
blah 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 blah. How you doing? Um. Yes. How are you doing? I'm basically trying to get through the rest of the Mono game tutorial, and then maybe we can move on to Godot or something. We'll see how today goes. Void handle input, and we'll just saying that as our function call. Uh, so that. There we go.
Aren't we all?
Yeah, meh sounds about right. Very little sleep, or not enough sleep, too early get up, but all is good. We're back at sciencing the shit out of this sort of thing. Oh, nice, and enjoy. Take it as for your job. But yes, I am at the moment just sort of implementing the slime movement, well, snake movement, whatever. Um, but I'm sure you, my friend, are actually curious about something else entirely. I mean, workspace. We have a successful build. Oh God, that may have been a terrible thing to do. Okay, there's no job. Okay. Um, got CMake. Let's use Ninja, right? It compiles. Um, uh, and if I now run Ninja itself, right? We should have a hello Raylib, and I can then go and say hello Raylib, and we have a Raylib window. I have even implemented the exit lesson, the little exit window, yes, no, and we have frame independent movement on the top one. I needed to get that right in my head, because it doesn't care how many frames per second we are running at. It will always move the same amount of pixels, so to speak, whereas the bottom one is frame dependent and will thusly speed up and slow down. But yes, we did actual do C++ things. I'm quite proud of that actually. That I managed to get that working. But today I want to focus really on this and see if we can maybe get to the end of this. um, so only allow direction change if it is not reversing correct. Mono is going well so far. I know it's a terrible disease to have, but it's going well enough for me. What can I say? Oh God, it's one of those days. Bad jokes, bad puns. It's fine. It's fine. Um, so vector dot. This prevents the slime from backing into itself. But how does vector dot do that? I have no idea. I think I'm gonna need to take a YouTube lesson or something on vectors and these different operations. Like, was it? I think unit X, if I'm not mistaken, right? Unit X is essentially a return between 0 and 1 of the X component of that vector. And obviously, if you do a minus unit X, then it's a negative value there. But I think that's what a unit vector is. But this is sort of really where I'm struggling with the comprehension, because I don't. For me, vectors are just arrays of numbers. I know that much, but how that relates to 2D mathing is not always quite clear to me. But it's fine. Um, So now we implement movement. That is also a private void move. You can move this way, you can move that way, but you got to move. So let's go through that. We'll make a new slime segment called the head. Well, oh, we're getting more head apparently. It's segments. So we're grabbing essentially all our segments, and we're grabbing the very first index, right? 0. Something like that. Okay, that I understand as well. Like I can see that actually working in some of the code, the vector being a position or a velocity, and that you can add those up, and then that leads to a new position over time if you like that's fine. It's the dot, the unit x. What's the other vector operations? There's a bunch of them. It's what those operations do. That is my problem, and they miss the part I don't understand. And basically, I finished school at a really, or I got kicked out from home at a really unfortunate time in schooling where I should have learned all this, and we would have probably in that year covered all that, but it wasn't supposed to be. Because I remember us doing a whole bunch of different vector things all over the place. And ultimately, yes, as I say, I understand it's a position and a vector in this case, for example, and mostly is in game development as a matter of fact. But what these operations do with that vector, or why we do it, no. And I think it's the why that's really important. Why you do a certain vector operation on a vector to achieve a different result is like, like what makes, I mean, I understand unit X is different from unit Y because it obviously operates on the different component of the vector, right? That's also fine, but huh? And this is something that I don't know if this is a problem I find in programming in general, but whenever you do any tutorial, you follow any programming course, these concepts are not explained, they're just assumed to be known in a way. It's sort of this implied knowledge that I was talking about yesterday, and then it is what it is. So we're gonna say head direction. No, I don't care what direction the head is, as long as I'm getting it. It's I can't be helped. It's fine. Don't worry about it.
I wasn't offering to help you.
Oh, you could help me with that, but no, okay. Let's not
You
even.
can't.
Oh, that one I get. That one I understood, and this is how we done circle collisions. That one I still know, but it's like I'm missing a piece of the puzzle in terms of knowledge or understanding. Up the head's eye position to be where it was moving to exactly, and then the new head to position is basically head at plus direction times stride. So how fast we're moving. Okay, that makes sense. Head at plus head direction, because we can basically now do vector mathing here. No, plus times the stride. And by the way, I'm not explaining, expecting chat or anyone to explain this on stream. Like this is really an exercise that's left to the viewer or myself in this case to the streamer, to really do and figure out. I think because I can't keep being this clueless about something that's obviously really important in any sort of physics simulation, game simulation, whatever. Like it's all really is part of the same thing. So sorry, I'm struggling with cables here. You there, out of my way, please. Sorry, we now add a segment, we insert. I can insert my digit somewhere. At index 0, we're adding another head, basically. Another head segment. That makes sense. And then we'll remove the last one. Okay, that makes also sense. Segments dot remove at, I think. Right? Yeah, and then the position. Segments, is it? Segments dot, is it count? Yes. Count -1. Because we if we want to know the last index and we want to remove it, the count will actually lead to an index that's +1 because every array, everything on computer science, at least in C like languages, is 0 based. So you actually, the first index is actually 0, meaning if you have 16 items, the last item is actually indexed at 15. Right, so this is why we need to take the count, but actually take one away to get at that last segment. And then we're doing a little cute little for loop for int I until segments count, right? Okay, yeah, until it's smaller than segments don't count. And then I plus plus it. Right. Just increase that counter for us. And then what we're doing here. Slime segment is segments I. So we go through the individual segments. If head add is equal to head add and body collision is null, not null, then we invoke it. Okay. So if head at equals segment. Oh, yeah, segment. I forgot something here. Yeah, I forgot to actually make the slime segment called segment first. And it is basically counting from segments at index I, because we're looping through the entirety of this. Scheiße, ja. Good segments dot segments at. Not segments, just a normal singular one at. If those are the same, no. Yes. I need to wrap it one more time because then we say if body collision is not null, right? Then body collision begin invoke. No, invoke. Yes. And we invoke it with the context of this and event args empty, apparently. So we pass in ourselves as a slime, and we have the event handler for the body collision, which I feel like the actual handler isn't done yet. But that could well be. That could well be that is still to come. But yeah, basically we then say body collision invoke the event handler that we've assigned to that, and then push out. So then that basically finishes off the move function. And now we need to learn how to grow when we get head, right? Just don't say it, okay? Don't say it. It's fine, honestly.
Get ahead in the break.
Apparently I do. Informs the slime to grow by 1 segment because it got head. Sebastian, stop it. Stop it. Slime segment tail is segments of index segments count -1 obviously because array indices. Create a new tail segment that is positioned a grid cell in the reverse direction from the tail moving to the tail. Excuse you. We'll probably see this easier in the mathing if we go and look at it. So we'll make another slime segment and we'll call it the new tail. And it is a new slime segment being just invoked like thusly. New tail dot at is tail 2 plus tail reverse. Hey, Sprocket, what are you doing at this time of the morning here? I mean, welcome in, of course, but holy shit, it's got to be early for you. Plus the reverse direction times the stride because we need to account for the movement of our slime or snake, whatever. And then we say that the new tail, where it's going to is basically where the current tail is at. Right, and this is essentially now what we're doing there as well is that we're following up with that tail where the head was. We're literally following along in this sort of list of movements. I can literally see it sort of unwrapping here in code. The direction is a new vector 2. And that's another one. That's another one of those vector operations. Normalize. Why you not happy? Why you complaining? No quick fix. Are we using that wrong damn namespace again? No. Two seconds here. I want to check my imports. Sorry, my usings. There is no reason why you shouldn't be able to normalize that. Let's just continue. Vector 2 normalize tail dot at minus new tail dot at. But yeah, you is not happy. I'm not sure this is correct. Oh, I'm a bit of an idiot because we're not making a new vector from this. We already have a vector. It's called direction. No, new tail direction. We just invoke a static, I think, function. I think in this case. I almost have a feeling this may be a static function or something. But we have an instance in any case of a vector, and that's why we're just calling normalize. And we can't do that on a new vector, of course. But you's not happy. I think that's just formatting. That's just me being not done here. And we then say segments add. Missed anything about? No. Sorry. Add new tail. add that new tail segment basically into our entirety of a snake. Now we have an update function that we need to go do. Let me go and just if I paste this in, this actually already tells me the function declaration essentially. Public void update. It hasn't got a return, so it's a void, and it takes in a game time object. So you know, well, why don't we say just exactly that game time? Oh, game time, and then we'll just call it small game time, and we already have the function declared. Okay, using are still okay, fair enough. So what we're doing, sprite update, handle input, okay, all very straightforward stuff. Sprite update, call into that, right? Yes, of course it needs a game time. I should have probably guessed by the message itself, but check input. No, handle input, I think it's called. Yeah, handle input. Then movement timer, okay. We now say that movement timer gets increased by game time elapsed. That's your delta time, right? We're just adding to that movement timer. And then we say if the movement timer is larger or equal than the static movement time, it's basically a threshold. Maybe we should have called it that, but yes, if we've basically passed enough time to be able to move our slime segment, as it were. We then say, hey, movement timer is taken away the entirety of that movement time. Right, okay, basically just resetting by the amount of time that has passed. Yes. And then we also move. You can move this way or you can move that way, but you got to move. I like to move it, move it. I like to move it, move it. You're welcome. Float. Well, casting into float was this movement time total seconds divided by. I'm just wanting to copy quickly the commentary for this. LERP linear interpolation, I think. Not that I know what that means. Movement timer total seconds divided by movement time total seconds. Every time I hear LERP, I have to think LARP, like in my mind. I'm thinking of like actual role play. I don't think math. Bless you. Gesundheit. Now we need a draw call. We good? Yeah, we're good. So for each slime segment, right? But that's the type segment in segments. That's our collection of segments that we're working through, and we basically say, hey, each of those segments is actually an element of type slime segment. So that's how we basically do this, and then we can say we can do something with this individual segment that we've basically pulled out of the entire list as we're working through that list. So we apparently make a new vector to position. There's another vector operation that I will probably never quite understand, but we apparently do a lerp on it and say segment at from a segment to and movement progress. If I understand this right, what a lerp for us does in this case is, how do I explain this nicely? Because it can't exactly know how many frames have passed, what it's going to do, it's going to use the time passed. I think this is how the movement progress ties into this, and say, okay, this is where I was supposed to be, this is where I was, this is where I was supposed to be, but only this much time has passed, so where should I be right now? It's I think that's what it's doing with that lerp. To sort of draw a conclusion on where it should be based on time elapsed as well as the two new positions. Right, and then we just do a sprite batch call. Or sprite draw call, sprite call. Okay. Yeah. Maybe this will help us. So vector2 lerp performs a linear interpolation between two vectors. So that's I had the naming already right, creating a smooth transition from start to end based on an amount parameter. The formula is result equals start plus n minus start times amount, where the amount parameter ranges from 0 to 1. Visual fluid movement illusion by interpolating between a segment's current position and its target position based on the elapsed time. That's exactly what I was trying to, I think, express there. But instead of instead of us just having these jumps, we'll actually get smooth movement because along each frame and each elapsed frame call or update call, it will actually know, okay, this is where I should be in between those 2 points based on how much time has passed right now. Ah, welcome in, blah, blah, blah. Welcome into Twitch, yes. So that makes more sense then, I think. Let's find out, shall we? 2 seconds. I'm just looking at something. Don't think so.
Don't think so.
No. 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 Cool. So yeah. I sort of get what we're using alert for here. So the result of that lerp is, I'm trying to think what we're doing here. So we're wanting to know our sort of future position. We want to know where our thing, doesn't matter whether it's a segment or a ball, whatever, but our thing, right? This is what we're looking at in result. Yes, hello. Nice to have you here, by the way. You get to hear the soundtrack of my life, as it were. And this result is the amount is the movement, right? That's essentially the amount of time has passed, so to speak, or the amount of frames have passed, whatever. We're saying start plus and minus start. Why? So we take the end position, we take away the start position. Right, I think I get it. I think I get it. It's essentially looking at the difference. Yeah, the difference of where it should be and where it started. But because of the amount multiplier, you actually end up maybe only halfway there, and that's the result we're getting. That's why we're doing the start and end minus start. I think that's where that's coming from. I'm not sure if I'm expressing myself even very coherently here, but it sort of makes sense to me why we do a lerp. Okay, cool. Now here's our get bounds call. Circle value represents collision bonds of the slime, and this is again the same thing here, what we're doing with the visual segment. And then we'll do the new circle or the next collision. This is essentially for collision detection, what we're using this for. We're taking into account the height and width of the size of the graphical object. Obviously, only half of it to actually get at the center point. Same with the sprite width, so that all makes sense, and then we return that as a bounds. I'm just going to copy and paste this. Like this is something we've done before, and the only thing that's slightly different here is the new position being done through a vector lerp. But this is basically just us saving having to do this math manually on each vector component. That's literally all vector lerp is giving us there. Let me also grab the document. No, I don't need to. Draws the slime. And we probably need to import or using our library itself. That was the bounds calculation, and now we need to do something for the bat as well. First off, I think I would like to see if it builds. Are we in the right place? Yes, we are. Make clean, make yeah, sure, make run even. This is not going to fail, I'm sure. Actually, as long as it builds, it should run, because we haven't implemented any of this in our actual existing code, so no code path is going to lead in here. Yeah. Perfect. So we're still feature parity, basically. We were on feature parity. I love to see that. I'm actually noticing it is my break time right about now, because we then, as a next thing, we need to work on the bat. It will have very similar functions and properties all across the board. We've got a velocity, we've got the actual sprite for the thing, or even a sound effect that we will use. Position. Here yeah, it's just constructing it. We calculate our velocity. Okay. Why are we doing this again? Me missing high school math. Math cosine y for x, y for y. Why do this? I have no clue. We'll just copy it. And this is just assumed basic math. I imagine this is why they're just sort of washing over it. So bounds is essentially taking our new position and making it bouncing off vertical left and move slightly away from the wall in the direction of the normal. So we're basically moving a little bit over in terms of how wide we are, so we're not getting stuck. Whatever that means. And then apply a reflect on that on the vector, play a sound effect. But this can we can probably just copy a lot of this. Let's just stop there. We will probably try and make our best effort to understand, of course, a lot of it, but some of the math stuff is just above me. I will be honest, but it is what it is, and it isn't what it isn't. With that, guys, if you like this sort of content, a like, a follow, a subscribe, every single one of those, or any one of those, I always appreciate it. I will be back in 3 to 5 minutes, and then we shall make a bat. I'm Batman. But anyways, I won't be long. See you all soon. And with that, I am back. So let's get into this. I will need to change soundtracks because we're nearly at the end of this album. Thank you, thank you, thank you. Let's have a look in my other collection. What we're gonna go for today? I think actually I want a bit of. Thank you. Where is? Let's go a little bit on the safer side. Let's go a bit of French quarter. Yes, good. Let's make a bat. Just another game object, right? Bat.cs, I think. Literally just sure. And let me go and namespace this into slime dodger dot game objects, and it's a public. I would have imagined class bat. Off we go. It's represents the bat entity and all its properties and functions. Something like that. There we go. What are we doing first? We have a bunch of fields. I will just copy and paste those. Like literally, this is just busy work. Otherwise, putting a bunch of variables in. No, damn, wrong one. Wrong one. Vector 2 is meant to be coming from the XNA framework, and we're just using our own library, please. We keep a track of the bat position. Another vector 2, of course. We then have a constructor where we say that the sprite just comes in. Just this is at the moment. This is now becoming almost boilerplate-ish because of the amount of times we've done very similar things here. And then the random velocity. Okay, what we're doing here, that's a bit of an interesting one. We'll probably need to try and grok it a bit. Nope. Copy. Paste. So what's happening here? We make a random angle by doing this thing. We get a random float, basically what this is, and we times it by 2 pi. And that somehow ends up being an angle. And then we need to take that angle and somehow do cosine and sine on it to end up with x's and y's. Why that is a thing? But that is what's going to make our new direction, basically our random direction that we're going to take off in. And basically we're going to say, hey, our velocity is the direction times the actual movements, that speed that we have. It's set in U. Okay, that's fair, I guess. I would like this probably exposed at some point, but bouncing. The bounce. There's something not right here. You are one too many. So what is happening on the bounce? We say that new position for now is equal to our normal position. Normal x, normal y, based on the normal. What is normal? What does that imply? I what is a vector normal? Like a normal vector is a vector that is perpendicular to a specific surface line or plane at a given point. If I got it, if I this this honestly, I'm gonna say this is down to me not finishing schooling. It's as simple as that. Like why Do we need a normal here? Why are we asking for this? I mean, we're basically saying if the normal ain't zero, right, then we're going to make a new position by adding our current position, which is, initialized up here as that, and its x is going to be added from the normal of x times the sprite with times some little offset. Oh no, this is why we're here. Because I'm learning. This is exactly why we're here. Okay. And why use it when calculating collisions, for example? Like, I know we've said no AI, but I think we can all agree that AI may actually be a good little explainer for weird concepts, right? We're not going to use AI for code, of course not. But maybe it's going to help me just grok why we fucking do this. Okay, a vector normal is a you keep repeating the same fucking shit. It's fine. It's fine. Is a vector perpendicular to a surface or edge representing its orientation? Okay, used heavily in physics engine that defines the direction of impact, allowing for the calculation of reflection, impulse, forces, and separation axes to resolve collisions. N is the surface normal. I think I'm actually starting to get this. Like in a very obscure and I can't put my finger quite on it yet way, but let's go back to the actual check. What we're actually saying. What are we saying here with this normal exit? Because it's a position. It's not a change in time. It's not a velocity as such. It's although I think it makes no difference if we handle it that way. But what we're doing is we take the two positions, or the two components of the vector. We're grabbing the x, but we're not just interested in exactly where that position is. We're actually interested in it in a limited fashion. We need to. Isn't normalizing just making it clamp between 0 and 1, I think, in a way? Like, I'm looking, I'm trying. Break the initial momentum into x and y components. We're going right back to what you said on YouTube, by the way. We're going right back to Pythagoras. A squared plus b squared is c squared. This is why we're doing it. We need to establish the reflection angle because then that gives us 90-degree angle inside to do anything with, to do distance calculations based on. That's why we're doing this shit. That's why we're asking for the perpendicular of our direction, which is going to be always a reflection of wherever we hit, obviously, in this mount scenario. And by having that angle present, we have a fixed 90 degrees, which gives us our A, it gives us our B, and we can then say, okay, what is actually the difference there for that movement vector, the actual C And that's what we're wanting to know along that line. Did I get that? Did that make sense? That, like, in my head, that seems to now sort of click. And we're doing, of course, the same with y, and the only thing we're doing here with a minus times 0, 1f is we take some of the width and we'll say, hey, I don't want you right there on that boundary, I want you a little over. But just make it based on how big your actual sprite is. And then the position becomes the new position. We now need to normalize that, I think, again. The normal wouldn't have changed, though, here, would it? So we got in a normal vector of the surface the bat is bouncing against. So it's actually right. It's actually where we're actually asking for the world's normal x, given that we're wanting to be clamped into our position space. And yeah. This is now starting to come together more and more. Okay. And then we take our velocity and we do the reflection of it to say, okay, this is how you bounce off. But we need to apply the normal to actually put this all back into a scope that we can calculate it off, because some of these values might actually just bounce right off the or over the 0 to 1 scale. This is why we keep normalizing this. I think that's so. Yeah, this is easy. X is basically just get your position and add the sprite's width half of the sprite's width, so that the radius. Right. Same for the Y. Radius is literally sprite width a quarter of the width. Quarter of the width Y. That seems weird to me at the moment, but I think this is actually to do with the fact that we're scaling our sprites 4 times. But yeah, that one's easy enough. I'm not going to argue myself argue long about this one. There's nothing to argue about, basically. Get our shapes library imported, and then we will do the update function, which is sprite update and position plus equals, so we add our current velocity to our position, basically. That's simple vector math. The simple vector math. But it is actually really simple, because if you look at 2 vectors, x and y, literally just look at the 2 numbers, and you want to add another vector to it, you take the 2 x components, you add them, that's your first new component of the new vector, and you add the 2 y's together, and both there's your x and y's. But that's addition is simple. I think multiplication works the same way as do the other operations. I think it just gets more verbose and more written, the more dimensional your vector is. If you have a 3-dimensional vector, you need to write this out 3 times, but it still works the same way. Yeah, draw call, nothing special happening here, honestly. Like, we've done this many times now. Oh, let me just, really? Thank you. Yeah, I was going to say, we haven't hooked any of this in, because apparently this finishes off chapter 22. And the only way we can actually confirm that it would be okay-ish is we're going to try and build. Even though there's no code paths leading into this, the compiler is actually going to still try and compile all this anyways into one coherent unit. I think it would. Yeah, no, it will have to try and compile it. That's I think. Make clean and just see if we can make a debug build. Okay. 3 errors is not good. The name random doesn't exist. Well, let me guess. You just miss using system, right? Was that all you were missing? Yeah, that's literally what it was. It was just missing the system library there. Okay, sure. That should build now. Come on. We have a successful build. I'm sure it would also run. I need to work through my makefile because it shouldn't need to do a clean now. Like full rebuild shouldn't be necessary when I do a run. That's a me.
Possibly.
But yes, we still have our functional game. Sweet. Um, Sweet. Let's go commit. Commit. Was changed in game scene. Yeah, there's a bunch of imports we had wrong there. But I'm not just gonna say we've just implemented. So finish it chapter 22. And we're gonna say we have implemented slime and that game objects. Implemented slime handling and game loop. I saw the main game loop or main words are hard. Main game feature and snake-like feature. We'll call it that, right? What else? And then we'll call the other one just a refactor of wrong or missing usings. Something like that. Also implemented game controller. Right. Yeah, that'll do. Commit. Sure, sign it. I have also gone and fixed my signing issue, and it turns out my local Git settings actually had the wrong email address. That's why every single commit was coming up as, oh, this isn't really right. Because the commits coming in were coming in from the wrong email address, so whoopsie doopsie. Yeah, it's fixed now. I've also gone and, by the way, the two repositories that we've been working on in the last couple of streams, they are also now mirrored on GitLab. So if you have issues accessing the Codeberg repository, there is always going to be a copy on on GitLab. What I'll probably end up doing is have a little webhook or something that will make pushes straight into this mirror when needed. Because I believe if we now go and check out chapter 22, for example, I don't believe we would see those changes right now. No, not necessarily. I would have to do something. But there is a mirror, accessible and available. But yeah, let's. Where is? Oh, of course, this would have not happened anyways because I forgot to put it in my passphrase, and we need to do this again. Yes. Shoot. No, I was just wondering what you were doing. Glad to see it.
I said I'll do this finishing.
Yeah.
I've still got yours up, so.
Yeah, it's all good. I don't think there's like an automatic push involved at the moment. No. But I should see these updates here, right? 2 minutes ago, thank goodness. And yes, there's our green now confirmation that we have signed this and we actually verified as well. So it's a verified GPG key, and I'm really happy with that. Doing it nicely and correctly, so to speak. What do I know about doing things correct, anyways? But here's our pull request for chapter 22. Opened that yesterday, apparently, and we have finished. So we can now say, make it create. No, no, not like that. Not finished like that. I'm finished with something here, not with my stream. Go away. And make it so. I could have even done a signing from here, I think, but not important. Just curious, did this ever update recently? Yes. Yes, I've looked at the GD script and I just don't like it. I just plain don't like it. I'm more happy. I mean, we've obviously established yesterday language doesn't really matter, but like, why go on and put myself through more friction? I'm used to the language features of C#, so why not stay there? Do you know what I mean? Yes, come to me, my children, changes. Come to me, children of the night.
Yeah.
So now we
That's
go
enough.
and say we're now after completion. I like a good completion. I like to be complete. I mean,
Right then. Right then. Well, that's enough. Down.
I'm so I've thought about this for a while, honestly. I feel the Unity experience is just too much for little old me, right? I'm just in a business right now, as it were, for making a simple, somewhat maybe physics engine game, whatever. But I feel like the feature set of Unreal and Unity are just too much for me to even grok. When I look at their interfaces the first time they open up, I'm like, I have no idea what I'm doing here. And every time I do the tutorial, I still don't understand it. And I've done the Godot tutorial once, and I sort of felt okay with that, right? And for me, the point of learning all this at the moment the hard way is just so I understand the actual basic concepts. I do want the comforts of something IDE-ish for games. I don't want to go and reinvent the wheel every step of the way. This is why I'm looking at something like an engine like Godot, Unreal, Unity, but I find, as I say, those last two are just too much. Do you know what I mean? So I'm not sure yet. I haven't really made up my mind. If there is an alternative out there, I'd be willing to look at it. We can maybe do a speed run of that. I can't see myself, for example, creating like this whole library that I would need. Like we've seen this in mono game. You will need something like a library, something reusable that is sort of agnostic from your actual game, right? I can't see myself recreating that in Raylib or SDL or SFML or whatever system. Just no. Like I feel just still at the moment the friction of learning all the C++, it's just, how do I say, I want quick completion. I want a quick payoff. And I don't feel like wanting to learn the idiographic. I can't English at the moment. Um, I don't want to deal with the syntactic sugar of another language right now, for example, and the way you have to learn everything new there. I really don't know at the moment. So we need to make a game scene UI, which is actually coming with gum form controls. Oh God, I hate it already, but we're gonna do this. We're making a bit more UI stuff. These can go away. The game controller can go away. The segment can go away. Texture region we don't need. We know what a circle looks like. Scene slime dodger, a bit pared down up there. So let's go and check. This is not in the library. We need to be in UI and make a game scene UI. Oh, okay. So this comes from namespace slime dodger dot UI. That's where we live. Let me go and grab the imports that you want. There's quite a few of them, if I'm being honest. And no. Novice game library, please. Game scene UI derived from container runtime. Okay. Yeah, fuck that. UI construction, not my thing. What are we doing? We make a sound effect, a panel, literally UI stuff. Oh God. There's a bunch of events that we need to go and add. Yeah. Yeah, so every single choice sucks is basically what you're saying there, and I refuse to believe that. I always think that yes, there's maybe in this case three devils, but you've got to make a deal with one of the lesser devils if you have to, right? Because as I say, I'm not going to reinvent the wheel every single time when I want to spin up a new project. But I agree with you on Unity. Just no, okay. For many reasons actually. Unreal isn't as bad, but I think the problem with Unreal is mainly, in my opinion, it's too easy to fall into this trap of, oh, I want something really gorgeous looking without knowing and understanding implications. And you need to be a low-level coder to really deal with those implications and not have performance drops. Yeah, so for example, when you're talking about Godot, by the way, using C, C++, they mention it in the tutorial, for example, but there is not a single line of code showing you an example on how to do their shit in C++. However, the tutorial does very well cover it in both GD script and C sharp. So, that's why, again, I just sort of decided to go with that one. Uh, it's just so much boilerplate here for making UI, and I hate it already. I mean, look at all this shit. My God, it's just nope. And I hear MGUI isn't much better. It's pretty much exactly the same, just tons and tons of boilerplate to make a UI happen, and now comes some event handlers. So let's maybe look at those quickly. They should be fairly easy to understand. So when we hit resume button, basically I had the pause panel. If there's no resume button, click invoke the event. Sorry, if the resume button click event isn't null, invoke it. Retry button, pretty much the same. Show and hide some panels. Nothing all that exciting. Like, this is literally just so much bloody boilerplate. All right, interesting. Um, just gonna say it's not an AI thing. Surely not.
Practice enough.
Mm-hmm. And I'm already perking up at this, yeah. Mm-hmm. 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 I like that. I like that. I like that naming where that came from. Basically, he's derived from Jehovah, right? Meaning new god. He chose that because Godot actually means small god. So yeah, I like that. We're doing it right now, dude. This is my bread and butter. This is what I love. You show me a new framework, I'm gonna have a look. um, requirements. I need a compatible engine fork, okay? But hot reloading nested extension is only supported on the following distributions. I didn't even know there was different Godot distributions. Oh, come on. Why? Why? Is this on? Why would you? All right, okay. GitHub. Okay, so he has a GitHub. Yeah, I actually came from there, by the way, Sebastian. You're an idiot. Do we have releases? Let me have a look here. What do we have? Um, I like that he's compiled it against LLVM and GNU C. I like that. Um, but I don't. Give me the documentation again. You're saying I need a compatible Godot fork. So there is an actual Godot fork with Genova already installed. No, it's Genova compatible. Okay, do you have a release? You do not. Since we're asking the question, actually let me pardon that. Probably more likely to be found there. So if I now look for any Godot packages, oh my god. Uh, oh god, nothing. You're not. All right. Well, what do you mean? Okay, let me try and parse that. Let's go to engine org. Well, the implication here is that Godot itself isn't. Right, okay, all forks are capable of running the runtime, but hot reloading nested extensions. Is that something I will actually need? Because I can just add this to my own Godot, right? This is my point here at the moment. And then we have DCDM, whatever. Psycho engine is, yeah, sure. Techno, go, yes. Okay. Um, I'd be almost making a pull request for that. No. Sure, show off effects, not helpful. Where's your releases? You have no releases. Just. Mm, I'm trying to just find a download for some distribution for it. Huh. So you're showing off organized effects. You're not telling me where to download this, by the way. This is, really, it's a closed source project. So why have it on GitHub? It's fine. Yes. Uh,
Back in there.
it- yeah, there is literally at the moment no way to get this framework for me. I mean, this part is easy enough, right? Where's my give me the LLVM one, please. Copy that link. Works work. God, I can type honestly. Workspace apps. Go in here and let's just unpack that straight into there. Thanking you. The reason I'm not doing much more because, believe it or not, we're already basically good to go in terms of Godot. I have Godot. See, beat you to it. As I say, I have already done the tutorial once on Godot, and that's why I was quite happy with it. Genova SDK, GD extension, and this is where then breaks down for me. What do I do with this? You now need to make a project in Godot. Okay. Okay, let's just we're sciencing, right? We have fun. We're sciencing shit anyway. So, wait, yeah, that was actually cool. Godot engine mono. Let's go and create. It's going to be yes. We're gonna call this learning Genova because we're gonna move away from our mold, break away from our mold a little bit. No, I would like this, please, in workspace repos, like so. Okay, create, and then I imagine you're wanting to tell me I would need to add like a plugin into the actual editor, right? Oh, really? That seems a little foolhardy. Uh, are we sure about this? Really? Because I'm sure I had seen this. Like, there was always the assumption anything I want to install should be coming only from the asset libs. Uh, I guess my preference would be to make an add-ons folder, if I'm being honest. Try and keep things somewhat. Uh, so let's say I make add-ons. We go in here and we go and like so, right? Like literally copied in. May need to move it, so let's maybe just put you on the side for now. Pardon me. Now what? Add-ons. Genova. There's like a GT extension. And now what? You maybe projects at the top. Okay. Project settings, I imagine. So let's have a look here. Gscript. Found it. Sorry. Okay, it's not an installed plugin right now, so let's fix. I believe all I need to do then is move you up to here. May need to reload the project, by the way. No. He's already doing it. Yeah, we're gonna need to probably do a wait here. Or we broke... Oh, God. I broke Godot. It's fine, it's fine.
What's that?
It just crashed on me. It's fine, honestly. We're used to this. This is fine. This is nothing we haven't seen before. Edit. Nah, he no likey. He no likey at all.
You seriously broke it?
Because of Godot, they broke the 4.6 update, so basically I'm not going to get this to run. That's the bottom line here, right? I think that's exactly what we're on. Yeah, it's 4.6. So, okay. We can still rescue the project as far as I know. I can literally just go into no, not hello. Learning Genova and RF Genova. Oh well. Right, it really is. Notice that as well, yeah. Well, two seconds, because I did see mention in the documentation of possible resolutions for issues. You did say something somewhere.
The card battered me.
Well,
You attacked me.
attack him back. It's only Picard for goodness sakes.
You
Check
got
you.
somebody on YouTube.
What game? Oh, no. Nah, I'm not making a game yet. It's me just playing around with game engines at the moment. We are we are currently actually in the process of finishing off a monogame tutorial. That's actually sort of the main purpose today, but we're not making anything like I haven't got a brilliant game idea I want to put on Steam. Nothing like this. This is me learning physics, learning game engines, learning math even. But yeah. Okay. Take your time. What I would like to understand though is what missing symbols, Linux shenanigans. Um, hmm, we don't even know exactly actually what happened, do we? I don't think this would have been a kernel message. Oh, it was? Yeah, they seriously broke something. They seriously broke something in that update because we're sick faulting.
Yeah.
Thank you.
Yeah, about 10 minutes away from our break.
Oh, okay, cool. Yeah, that's fine. But yeah, this is our two events from Godot. Literally seg faulting on us, and then file a file descriptor dumb mapped. Oh, that's a threat safety thing. Somehow they broke thread safety. But yeah, okay, so not going to be a thing for a while unless we can find another release that would work. And that didn't seem to be an option because they're just sitting there saying, hey, we're not even released yet. Oh, God. It's just getting better and better. Okay, not going to happen that way. We have Godot Genova compatible, but that may need built by ourselves. Let me have a look at what he's got to. He's not got a release here, so that almost assumes we're going to have to build this. Is there a make file? Is there a CMake file? What are we working with here? Oh, God. I don't see any easy build orchestration. You didn't have any actions running, so how can there be a release of it? Sure. Oh, wait, there's a build system. But this is not it. This is not what we're looking for. Yeah, I think this is what do you call it? This is a red herring for us at the moment. But it needs to be basically a 4.2 distribution. So, and I don't see myself downgrading here. Like, no.
Yeah.
Like, no need. And there is no way we're running this on Windows, by the way. That's just not happening. Yes, I have a VM. Yeah, but nah. I mean, I feel yucky enough having a Windows VM in the first place, but I need it for some things, unfortunately, like slicing of 3D models for my printer. But it's such a shame because I would have loved to actually dive into this a bit. I'm gonna just keep the tab there though, so we can remember it. Okay. Let's continue with our actual things. We have a draw call there. Now we need to change things in our game scene.
Yes,
That should still work, yes.
it does work. You know.
Mm-hmm. Okay, so game scene is now completely different, literally. Much smaller. Um, Nothing here is a waste of time. Nothing that we dive into is a waste of time because ultimately I love diving into like different frameworks and projects and just having a look at it, right? So don't think of it that way. I'm due a break very, very soon, actually, by the way. I know. Um, and like truthfully, there is nothing stopping me to say, hey, gonna just have you running. Was that what, me laggy?
YouTube's just slower than Twitch, so
Oh yeah, YouTube always falls
Yeah.
behind for some reason.
it's only just came up with the redeem that did.
Yeah. But you know, we could just say, hey, we install it here once and have a look, if that makes sense. Because I would like to maybe stretch our wings a little bit if we can do something that I'm sort of familiar with, and then maybe stretch into the C++ realm, because why not? Um, but before I get lost in this, because that's going to be a little bit of work here to get this running, I'll show you how to do that, by the way. Because this is Tiny 11, there is no browser. I can literally go and hit start, Edge, no, nothing. Firefox, no, nothing. Is there maybe a Chrome? No, there is no such thing. We have a terminal and we have a very, very naked Windows. And I mean a very naked Windows. It's Tiny 11. I can only recommend if you're really interested in small, efficient Windows builds. 2 seconds. It's essentially a PowerShell script. You download a Windows ISO, you run the PowerShell script against the mounted ISO, and you end up with a new ISO that has basically all of that cut out. There's your hit pat. I'll just post a link. Check that out. Builds you literally a Tiny 11. So this is a fresh install of Windows, right? How do you think? How think you big? How big you think it is? Fully installed. 13.6 gigs. Can your Windows 11 do that? But anyways, with that, if you like this sort of content, give me a like, a follow, a subscribe. Always will appreciate it. I will be back in 3 to 5, and then we're going to quickly set up this Windows machine. Maybe try and just pull Genoa in and just for shits and giggles. This is a fully accelerated Windows VM, so we should have decent enough throughput. With that, I shan't. Are we applying a patch? Come see me. Come see me. Yes, we're applying a patch, aren't we? Yes, patchy boy. um, but yeah, I will be back in 3 to 5, and then we shall continue our journey. See you so soon. And with that, I am back. So let's get a little bit of a running Windows, shall we? What I like to do is I take a terminal. Why? Okay, try that again. Terminal. Huh? We should have an actual terminal program. Anyways, Winget is a thing, right? Yes. So Winget search. And for easy starts, I like to just search for Firefox. Let's see. And this is literally built into Windows, this Winget thing, right? Well, you can always do this. Thank you. And then let me go and grab this here string. This is the version I want to install. So winget install, sorry, source with a double dash is winget, and tells you at the very end which repository you're basically pulling from, and then what you want them to get, which is thank you. And why did you not copy that? Okay, let me try that again. Go up engb, this guy here. Okay. I hit the scroll button in the terminal here. Oh, for the love of. There. Insert, we'll do it then. And this literally will just grab a Firefox and present you with the installer. Basically, my Tiny 11 image also has an auto unattend XML, which essentially sets up the machine in such a way that there's no user account control. The antivirus is disabled. All that extra stuff from Microsoft is being removed. And just make the machine a lot slimmer. And sort of set it up with a, for me, sane default of Explorer settings even. So if I go in here, like hidden files are shown straight away. I should, let me confirm that. I should also have a, extension being shown by default. I don't need to do anything for that. I love that. Let me go and quickly search for .net. Come on. But yes, we now have a Firefox running here. Oh, that's my fault. I moved the wrong window. You don't need to do that in Windows, Sebastian. And what I want to install is .NET Runtime 10. This. So winget install source winget, and where's my insert? There. Go. Nope. Typoed. Of course I did. I think that's enough from Safer for now. Oh yeah, by the way, I've figured out more or less, I think, what's happening when you load the Genoa extension into Godot. It seems to segfault in file allocation, and this to me looks actually like a threading problem, or threat safety, I want to say. Something isn't being locked right, or we're obviously working with some memory file descriptor here. But yeah, things weren't happy when that happened. You're in safe pause, am I? Are you sure? Well, let's just skip this, right? Just go away. Coldberg org slash there novice prospect. Just to prove that we can actually just access this. I would need to join the Discord then and do a bit of searching, I guess. Yeah, of course it's a Linux only problem. But let me just, do you roughly remember, is the fix something you have to do in the actual code of Godot? Because it feels like it, or possibly even in Genova, but or is it just literally missing some library? Because we could probably just even what does that mean even? Right now, let me go on. You go away, but if I says yeah, mem fd double mapper. Why you know? Try that again. Mem fd double mapper. Hmm. Shared memory is used for allocating all executable for just-in-time compilation. Oh God! Are you sure this is a problem? Like, sorry, what I mean with that is this maybe specific to Godot Mono? There's a library, but it hates the location of GD extension. Okay, could be different. Yeah. All right, so it's on both. No, just when I see executable code for just-in-time compilation, that's a .NET thing, right? Where we're going from intermediate language to an actual a proper representation on the host machine, or on sorry, yeah, on the target machine, as it were. But I would like to just quickly, where's the documentation for this? I had it open and then I closed it. So where I went, we had a download somewhere. Uh, so if I go and sorry, yeah, copy link, right? We can do that and say, hey, go and grab this, please. And there's a Genova installer. Let's see what happens when we run it. But this also means we need to then install the entire. Oh God. Do we need to install Visual Studio? Please no. I wouldn't even notice that if I'm being honest. So I think what we're gonna do just now, we're gonna just ignore this. Wow, I'm not ready for this much unknown. What am I doing? So yeah, no, future set problems. Future set problems. Let's go and save this machine state as is. Go away. Excuse you. Are you doing this? Are we? Yeah. Weird. So you can go away, you can go away. We are back at chapter 23. Oh God, I made changes and I never even branched off, did I? Yes, yes, of course I didn't. So let's quickly do a git stash untracked files, because I feel like there may be. Oh God, I can type honestly. Sometimes. Chapter 23. Oh wait. Check out B. We need to make a new branch if necessary. Yes, some. Um, Git stash pop. Cool. So, refactoring the game scene. We've done that. We now need an initialization in the game scene. Sorry, in the game scene. So how is this initialization? We obviously base initialize. Let's give you the right using here. Initialize UI, initialize new game. Those are not defined yet. Come on. So there's the initialize UI method coming next, which should be like this. UI event handlers can just be added. How? Title scene, you should have access to that. Yeah, we haven't got a method for that yet. That's coming right now. Initialize new game is coming here. And it's literally just gonna set the slime's position basically up top corner from what I'm seeing here. With that position and the tile maps, the tile width as the we'll see that in a minute. Position bat away from slime. First, we need to do a bit of load content. Okay, that makes sense. But yeah, we're setting a score of 0 and we'll set the game state to playing. So we're basically inside our game loop, as it were. No. Why are you no happy with content? Because it's never been set yet. Collision checks. Position. Missing something somewhere. 2 seconds. Where is refactoring the game scene, right? Yeah, you're not making mention of content there. Initialize UI event handlers, load content. Yeah. Core content manager content, but it's never been defined. This is interesting. Sorry, I'm just looking through the documentation here, and there's right here the mention of it. Initialize new game. Initialize UI. There's actual initialize. I don't see an actual content here. Let me. Are we? Yeah, we're inheriting from. I think this is what it is. We're not inheriting properly because we haven't used this using yet. And I think that. Novice game library. Thank you. Hmm. That should now clean that up a little bit. Let's have a look down here. And I think we should be in a better position now. Let me where's the load content? That's what I'm. Yeah. Content is now resolved because we're actually getting that from our scene context. Okay, yes, that makes more sense. Whoopsie doopsie. So that was update. Then we do collision checks, which are happening right here. And this we know, again, we're literally just comparing where the actual collision position is and where our bounds are. Nothing exciting there, really. And then to position a bat away from the slime in the beginning, we look where the room center is. We need a library shapes. We make slime bounds. We calculate how far away the slime is from the center. We make the same thing happen for the bat. We give it some padding around, and we see that the new bat position is actually derived essentially from center to slime. New bat position. You're basically looking at whether. Yeah, basically whether it's too close. Like that makes sense. I can sort of parse my way through this. Makes sense. And then you center the bat depending on what comes out of that calculation. That's easy enough. Two event handlers. Then we have a draw call, in which we're basically pulling all this together. And yes, a lot of the stuff would need to be documented to really make it complete, but I'm quite happy at the moment to just soldier on and push ahead. Now we need to work on the slime scene a little bit. So let me go and say we have now done the game scene refactored game scene into game scene UI. Ooh. Oh, ow. Oh God, I feel for him as well as the project. This is just bad. Often commit little.
Ouch.
Commit often, commit little. That's all I can say. And publish or push as often as possible. Oh no. Hey King Zaiku, how you doing? Welcome in. So we now work on the slime class to input buffering is what we're doing. Okay, slime CS. Let's go and get that set up. After the sprite, we can do that. Put those two in here. We will have a queue of vector 2s, which is our input buffer, and the max buffer size is 2, which there. And initialization. Initialize, right? Input buffer. Oh, nice, nice, nice. That sounds good. Space Engineers is always fun. I am wanting to print that little engineer that they had on the Steam, you know, on their news thing. I have the model already downloaded. I will show it off once it's printed. So I'm just trying to decide whether I'm going to do it in white or black. That's the two PLAs. Sorry, bless you. That's the two PLA colors I have, white and black. So still trying to decide. I'm thinking black though. But sorry, input buffer is a new queue of vector 2 of size max buffer size. Yeah. Then, as we handle input, that's a vector 2 potential next direction is okay. Instead, it's not next direction. It's actually a vector 2 0. Vector 2 0 for now. Go and do your formatting thing that you wanted, and then patch enough. After the input checks, this is basically replacing this entire block. So what we're doing, so if a new direction was input, consider adding it to the buffer. Potential next direction. So if the potential next direction is not a vector 0 and the input buffer hasn't exceeded the max buffer size, right? Then we validate against, meaning we look at the input buffer count and hope that it's bigger than 0, meaning we actually have something in the input buffer. If so, return that last item from the input buffer. Otherwise, return the direction that our first segment, our head, is basically pointing. Okay, this is a link, system link. Yeah. Then there's this dot thing again. Okay, I need to learn more vector mathing. Okay, what is a vector dot? A dot product, it's called. Okay, the dot product of any vector with itself is a non-negative real number, and it is non-zero except for the zero vector. Excuse you. It's an algebraic operation taking two equal length sequences of numbers vectors and returning a single scalar number. It is calculated by multiplying corresponding components and summing them, representing how much one vector goes in the direction of another. Measures how similar two vectors are in direction. If perpendicular, the dot product is 0. So what are we doing here? We do a dot product of the potential next direction. against whatever comes out of this validate against, which is either the last direction or the next, no, the last item from the input buffer queue, or obviously the direction that our segment is already heading towards. And basically what you're saying here, or what you're expressing is, I'm trying to word this as well. What you're basically asking for in this if expression is you are wanting to make sure that we are wanting to move in any other direction but the direction we're already moving towards. Greater or equals 0. And but then basically we enqueue that next direction into our input buffer. I understand roughly what the dot product tutor does, I think. Roughly. Now we need a move function. Oh no, we need to change the move function slightly by saying we have an input buffer up here. Let's just literally just dump that in there. No, that was wrong. Excuse you. There we go. What else are we doing? Nothing. Okay. Okay. This should essentially build. Make clean, make debug. Does it build? Or do we need to fix some fucky wuckies? I imagine the latter to be the case, if I'm being honest, but it's fine. Oh, we have errors. I'm sure it's just import. I can almost guarantee it. Title scene. You were missing an import there. You were missing an import there. Same problem. Title scene. You already that's already resolved. I think that's it. Shall we try it again? Make clean, make debug. Go, do. Nope. Still 3 errors. Really? Oh, guess who didn't save their changes?
Yeah. What was that? Save often? Save little, saved often?
Well, that's different than what I was saying is commit often. That's when you put it actually into Git and when you make every little change that you make known into your history. Yes,
That's
yes.
saving it.
Shh.
Don't tell me to shoot.
Yes. Good point. Oh,
I thought you needed that.
oh. Thank you. I'm not sure if I should actually thank you. Ow. No, it's all good.
Either you crack your back or I do.
I'll take the latter. No, this should. Yes, Shuddy Bob.
Ha! We just cracked me. Yeah.
Ah. By the way, size of my coffee mug, right? Big as my head. And that's my second one today. Third?
Songify working yet?
I have no Songify, no. But I can add something. If you tell me what you want. Is it the
Yeah.
50s thing?
Huh?
The 50s thing?
Uh-huh.
Uh-huh, okay.
Come on, it's been ages.
Yes.
Cashman.
Yes. Give me a surfing bird. I want to Can I say I want to play this next? See what happens if I say add to queue, does it? Yes, ha, perfect. I have missed things on chat. I missed, no?
Just
Yes?
King.
uh, I guess we would do the tutorial again. No, we wouldn't. Yeah, so these are normally actually tied into something called Songify, which, allows me to have chat do things to my Spotify. But yeah, that works at the moment not so well, but we can do manual things, of course. Oh, by the way, we build. Yes, we have a bunch of warnings, but it's just documentation right now. I don't. Do I really care? No, no. Let's just run this bastard. Do it, do it, do it. Bird, bird, bird. Bird's a word, bird, bird, bird. Bird's a word. And look at us, we have a game window. Let me turn down the sounds of it. We have. Oh, I game over already. Why I game over? I game over too quick. Something's happening to our snake.
Don't usually.
Just quiet, Joe.
No.
Yeah, I broke something somewhere. Let me. Where's the move on the slime? Is right here. Input buffer count, yes. Head, head direction, head add is head 2. Brrr. Yes, of course, but you do know that bird is also equal or greater than the word, right? Mau mau papa umau 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 mau mau umau mau mau papa umau mau mau umau mau mau papa umau mau mau. So handle input. Let's make sure we are doing other things right here. Vector 2, potential next direction is a vector 2, 0. And then after all the direction changes, so else if game controller move right, potential next direction is a vector 2 of unit x. That one's a minus vector, so that is fine. Right, if potential next direction, this was just copy pasted, so I don't see this being an issue. Right, that was just copy pasted. That should be fine. Let us look at the initialization, which happens just here, and it just makes the input buffer be a new queue of vector 2s in size of max buffer size. Okay, that's nothing special there. So the slime ain't the problem. Game scene. Here's the draw call. That was pretty much just copied in. Quad graphics device clear. It's not the draw call. It's this body collision thing. Initialize. Took a pause. I mean, pausing works. That's the unfortunate thing. That all works. It's somewhere in the event handling that we're doing is all wrong. Let me go and do the collision checks. Where find me collision checks. Yes, I'm. So if Slimebound intersects with a bat bounce, so that, you know, then that is when we should trigger. That makes sense. Then position the bat away from the slime, bat randomize the velocity, grow the slime, score an extra 100 points. But no, it's not a collision check though. Because what's happening is we're crashing into ourselves. That's where it's already failing. I think.
In. No, I don't know. Okay, right.
Hmm.
I don't. I don't.
I feel like there's something going on in the game scene that makes this broken. I'm trying to understand. I mean, all these functions that we've created beforehand, this was all just UI boilerplate. And I hate boilerplate like that. And as a matter of fact, it's terrible that we've got a code a file, which is almost 400 lines of code, right? But if you actually look through it, a lot of it is ignoring documentation, maybe. But a lot of it is literally just boilerplating this whole thing, and then the game scene UI is even worse. But nothing in here should it? Uh, let's just work from the top. So it's in the right namespace. We are called a game scene UI, and we're derived from container runtime, which comes from Goo deriving even, but yes, monogame gum. Literally just holding variables. This is a novel reference thing, don't care really. And this all works because we have a UI, the UI is displaying fine. All this boilerplating for UI is just horrendous. No, not yet. I take it you know exactly what I've done wrong. uh, we know the panels work. We know that events work because we have seen that do its thing. I don't think there's anything in the UI. It wouldn't. Hide the game over panel. 2 seconds. So where is? Retry button. Click. This is all fine, right? I mean, those events work. We've confirmed that part as well, so I don't see that being an issue. We then have update score text, which is literally just dumping the score in some format. Score format, where's that coming from? Us doing God this. Basically saying make everything zeros, display up to 6 decimals. That's how the format lives. Okay, fine. Update score text, show pause panel. That's all fine. Game over panel. Yeah, nothing in here. I can't see this game scene UI itself being the issue. Game scene UI. Am I in the right place? Yeah, and then here's game scene. That's what we've made there. Okay, let me try and figure that one out. Dungeon slime, yes.
Yeah.
Oh. No. Mm, yeah. I caused myself issues there by just blindly copy pasting. Lowest game library slime dot. Alright, that seems fine now. Just making sure we've got the naming right here, yeah. Slime dodger, same for the title scene, hopefully. Let's. Yep. I think this was actually more me, if I'm being honest, with naming things. Just looking through if I see any errors, but I think this should actually work. But basically, because I blindly copy and pasted, we had a file belonging to this wrong namespace, and I think that would have done a lot already. The actual collision check, I don't think the actual collision check is, well, sorry, it's the way we get to the collision check is the problem. So what I mean with that, if we go into our game scene and we do the actual just collision checks, right? This one is really straightforward. We make two boundaries: circle bounds, get bounds. We check with an intersects. We made this ourselves. We know this works because we've had collision working before. And all you're doing, if it intersects, right, you position the bat away from the slime, you randomize its velocity, you grow the slime, update the score text, and like there is nothing here causing us to die or to stop, to pause, to something like that. So that's happening before that. I need to so like there's this one collision check right here. So this is during update, okay? We update the UI. We basically say is the state game game over? Yes, no. If it is, we just return. So just run in through this loop to update the UI. When it's paused, we do the toggle pause on yeah. Slime update, bat update, and then we run the checks. So as we update the slime, we where is our update function? Move. I believe actually this may have already fixed it, just fixing the naming. Make clean and make run. Let's try that. All right, let's see. Well, we had movement into one field and then it died. I think we're not going to need to step through this code a bit. And literally just see what occurs. I'm just trying to think of a good breakpoint here. I guess we could do it as you move. Because we see the move happening, right? So it's exactly here-ish where then something happens and we break down. So why don't I just set a breakpoint, I guess right here. Why did we break? We didn't add a breakpoint here. Where are we? Title scene load. Title scene. Yeah, we just run. Yeah, there is a breakpoint in title scene, that's why. Let me go and remove it. That makes sense why it would break there then, right? Not what I wanted though. My God, we're already coming up to my next break time. Would you believe it? Let's go and... So we know like a lot of the UI stuff is just working inherently, right? That obviously just, there's no issue there. Okay, now we've stopped. We've tried moving. Variables, locals, show me. Right, input buffer count has nothing in it. That's exactly why I wanted it. This is exactly where we are right now. This is the breakpoint I did want inside the slime movement, so that once the slime moved the very first time or tried to, I wanted to interrupt there. Because this is where then somehow the game thinks, well, we're game over. So what's happening here? That's what I was getting at. Like there's nothing in the input buffer, and that actually really doesn't matter for that part. We get the head, which is a segment, right? And it has an at 640, 320. It has a direction, its reverse direction, and this is where it's going to go. Right? Makes sense. That I'm so far with this. We do a bunch of calculation there. 2 seconds. That already. Hmm. That already looks wrong. Is this maybe I wonder if this is a regression from chapter 22. So let me find the actual handling here of what's this, in the move. So initialize. Initialization seems to be fine. Yeah, handle input. Fly movement. Here's the movement. That's what I wanted to see. Segments and surge. This is head at plus head direction times stride. So I did that right. We then segment insert 0, the head segment, remove the last segment from our segment chain, and then for int is I relied on my standard initialization of a for loop. Let me point it out here. For int I is 1, we start counting at 1. Right, for the amount of segments. I'm starting at the wrong index. I smaller than segments count, I plus plus, that's still correct. And then we say that the next segment that we're looking at currently is segments of I of that index. Head at is, if head at is equal to segment at, then we say if body collision is not null. Yes, I know, nearly break time, and then.
I didn't do nothing.
All right. And then body collision invoke this event arcs empty. I think that was it. Oh, also missing a return here. I think this is, by the way, it. So let's just go and stop the debugger. And if we now go and remove this breakpoint, I believe we should be hunky-dory and Gucci, Tamaguchi, everything is good. Okay, so let's go and turn down a little. Yes, yes! I mean, I crashed into the wall, but... We made a game, guys. We made a fucking game. Would you believe it? And it behaves like Snake. That was actually very satisfying, I want to say. Oh. Yeah, by the way, we're done with chapter 23. We're now getting into chapter 24, which is shaders.
Yeah.
Yeah, you're fine. There's nothing for you to worry about. Shaders are essentially just actually a way to tell the GPU, your graphics processor, to do a bunch of mathing. Instead of your CPU doing it pixel by pixel, you can write a program called a shader, and you pass onto the GPU to all the little cores it has inside. You pass each of them one piece of the work, and there's thousands of them in some cases. And all of a sudden, you've got 1,000 or so CPUs all doing just a bit of addition or a little bit of vector math or something. But you do it on a big scale, you can literally change the look of an entire picture without having to iterate over every pixel because you've got, as I say, thousands of cores doing it for you. So that's what a shader is, and that's what we're going to learn next. I love it, I love it, I love it. Let's do a bit of code commit. Let's also, yeah, I like to close my tabs as I don't need them anymore. Like we are basically Gucci here. Well, it's finish it chapter 23. But what does that include? That included us implementing implementing, is it implementation? It's actually integration. Integration of features developed in chapter 22. That's one thing we done. Fixed regression from chapter 22. Movement checks, or yeah, it was the move initialization, yeah, right? Yeah. In movement fixed wrong unrolling of loop, something like that. We also implemented a new scene scaffold, I want to call it. Right, commit. Right, let's push those changes out. And we are getting actually very close to finally being done with this project, right? Where we're basically now learning about shaders. Then the next thing is going to be packaging. We're not going to push to itch.io. I just don't see the point there, if I'm being honest. Once we know how to publish, it's really up to the author or the reader as an exercise, as it were, to find a platform to put your game onto and publish it there, or maybe just distribute it through Discord or on your own website. Hey, it doesn't really matter. That's just a means to an end, right? But yes, I think this is as good a time as any to take a quick break. Remember, guys, if you like this sort of content, a like, a follow, a subscribe is always well appreciated. I will be back in 3 to 5, and then we will learn about shaders. And with that, I shan't be long. And with that, I'm back. So yes, introduction to shaders. First off, maybe I want to go and do a bit of merging, committing, all that. Thank you. Because I obviously did not do that just yet. So let's maybe make a new pull request. Thank you, kind sir. From 23 into yesum. You should be able to just pull in the requests from the commit. Yeah. Create a merge commit, yes. I think that's all we need to do. This should be fine. Cool. So let me go and say, hey, let's grab main. And then get checkout to chapter 24. And we might as well just publish that out straight away. And then let's find out what shaders. Important to note that this is an introduction to shaders in monogame and will focus on the basic foundation of understanding how to create a shader effect, how to create shader effect files, loading them through the content pipeline and using it in your game. HLSL is one type of shading language. You also have GLSL, which is the OpenGL version of that. They're basically just two different ways of talking math to GPUs. But if interesting is, there's links here you can look at yourself. Shader Toy, I have heard of. I don't know what it's literally, I think, just that. It's like a library of different shaders showing things. I like that one. But the description of the shader is okay. It's a GL. It's a OpenGL shader. There's a lot, and maybe there's a simpler shader to look at. Work one. Just show me. Okay, there's no real search for like something simple. Like there's a lot you can do with shaders, as you can tell. Oh wow, a curved black hole. Oh, and the check buffer A for the core rendering logic, and buffer B, C, and D are the image, essentially. Something to do with that, but this is essentially where the actual like what? This is way beyond what we're wanting to do here, but it looks gorgeous. Rendered in real time, by the way. Like that's sort of the point on of shaders, that you can do stuff in real time that you just couldn't usually do if you were doing it on the CPU alone. That's fucking amazing. Anyways, understanding shaders. Shaders are small programs that run directly on your GPU instead of your CPU, main processor. While traditional game code runs on the CPU and handles things like the game logic and physics, shaders run on the GPU and focus specifically on how things are drawn to the screen. And the separation allows for efficient processing and enables visual effects that would be too performance intensive to calculate on the CPU. What do you mean YouTube not receiving enough video? You sure? Is my stream dead or something? No?
No? Also there.
YouTube just being YouTube, I think. Okay, cool.
Keeps taking up a life, but
Yeah, I know. So there's two types of shaders. There's vertex shaders and there's pixel shaders. Vertex shaders process the corners, the vertices of the shapes that make up your game objects. They determine whether these points should be positioned on the screen and can manipulate their position to create effects like waves and ripples in water, swaying grass or trees, and character deformation for animations. Wow, okay. Can be used in 2D games, but mostly more important in 3D games, okay? Which involve, for special effects that involve moving or distorting sprite positions. Oh, okay. Even in 2D games like ours, Monogame actually draws sprites by mapping textures onto simple 3D shapes called quads. And the quad is literally two equilateral triangles, or no, any triangle really, any two triangles together to make up a rectangle. That's what a quad essentially is. But you then define through the three corners of each triangle, and the two corners that are shared then become essentially that merge point where it's becoming one texture. And then we have pixel shaders, or sometimes they're also called fragment shaders, because in the pipeline it was used to be actually fragments that the GPU was working on. It's just how NVIDIA called it back then. And they determine the actual color of each pixel that gets drawn to the screen after after the GPU figures out which pixels need to be drawn based on the geometry and so forth. The pixel shader then calculates the final color for each of those pixels, and that's where we probably come in and we could apply an effect. You could do color adjustment, visual filters, special transitions, dynamic lighting effects, and okay. This is the look at the shader pipeline, which runs the texture into the pixel shader, which already derives what it draws from the vertex shader, and then so this is where the vertex shader gets applied. The pixel shader itself takes a sampler and the vertex shader and makes the output. Okay. Uh-huh. Okay. So, okay, then you need to sort of be aware of the versions that are compatible with each other in terms of OpenGL and like between shader and vertex, between pixel shaders and vertex shaders. You want to pick probably something that has the same version. And okay, following shader models 409 level 91. So that's this one. Unless you want new features, then you would probably look at vertex shader profiles 4.1 or 5.0 even. But I don't think we care about any of that realistically. Okay, so there is support for Vulkan and DirectX 12 coming in monogame at some point. I don't even want to consider Vulkan. Just nope. So this is essentially the default shader fragment shader, pixel shader, that gets made when you just create one. So what does it do? If it's OpenGL, you have these versions defined. Otherwise, you use these shader models. But this is God, what's this called? A preprocessor directive. I think you call this in C. So you basically have a sprite texture. You sample it. And the vertex shader output is a struct which has a position, a color, and the texture coordinates. Okay. So this is the actual pixel shader here, and it returns a texture 2D. So basically, it returns a pixel value, color value of our current position on the texture where we would normally draw that part of the texture, or that pixel that represents part of that texture, and we add, or sorry, multiply by some input color. Okay, and then sprite drawing technique, pass 0 pixel shader, compile the shader basically with this function. Yeah, this is literally just a sampling over the entirety of that texture or whatever has been passed in, and we can basically say each individual thread that comes onto these GPUs has then an idea of which pixel it's working on and what it should look like, and then can do transformation on that. Right. Mm-hmm. Right, I sort of get this. Mm-hmm. As the sprite batch draw call comes in, this is basically where this technique takes over and says, okay, our pixel shader is actually going to be compiled from the shader model that we're in right now and run this function which, does our return of the pixel value, the color value, or whatever, the entire pixel essentially. A technique is like a recipe for rendering something. Each technique has a name, in this case sprite drawing, and contains one or more passes. Each pass is a single step in that recipe. For simple effects, you often just need one pass, which is why the template only has P0, but more complex effects might use multiple passes to build up a final result. So you like maybe do different color color filters and just layer them on top of each other, sort of thing. So this is a blur shader, for example. So how does that work? So we have a bunch of techniques. We probably need to start with that somehow. So the techniques are blur horizontal, blur vertical, blur horizontal split. So it does run a vertex shader as well as a pixel shader, by the way, I'm noticing. So there is a main vertex shader, which okay, it basically takes our current position for the output and multiplies it by the worldview projection something. And it's a representation of the 3D or 2D world in the computer space, so to speak. I sort of get that part. But okay. And then you say that that's the texture coordinate and return that as output. Like, I don't even pretend to know how blurring works or why it would work, but it's fine. I don't think we need to know exactly how all that works right now. But yeah, you just run this through a content manager. There's nothing special there. Then you grab that effect. So that's interesting. So the example effect equals, well, don't even need to do this effect colon thing. It's just a way of making sure you get the right variable before you need to know every single one. But yeah, and then you just make an normal sprite batch draw calls, and then automatically that effect is being applied. That seems straightforward enough. Shall we do this? So we are on chapter 24. Let me go and well, it's if it's part of the content pipeline, it would probably make sense to add it this way. Make a new folder. They want me to call it effects, but I feel like shaders. Yeah, it doesn't matter. Let's just stick with it. Effects, make a new item, which is a sprite effect, I'm sure we're making, right? And we shall call it grayscale effect. Sonnensfummeln sie. Mein schöner Leichtmatrose, stopfe mir das Leck. Now here comes the question, did we do this right? And how would I know? Oh, build succeeded. So, it did not. It did not build the effect. Oh, God. I don't even want to fight this. I honestly don't even want to fight this right now. We basically have the game ready. We can't do these effects right now because, well, we're it's trying to compile this on a Windows machine. Like we have actually followed the steps to do this through Wine, but I suspect because my Wine installation is actually fairly specific and very special because of CacheOS doing a bunch of stuff with Wine, I don't think we're going to get a compilation out of shaders. I'm going to try it one more time, but nah, it's just not gonna get a graphics contest. That's what's basically happening here. It's trying to get an actual, yeah, an actual graphics context from one of my graphics cards, and well, they're in use right now. Obviously, that's not going to work. So, yeah. Absolutely, absolutely. I, I don't particularly. Want to be honest here. Like the fact that we're not going to be able to finish this off right now, but fine. Honestly, fine. Let's just live with that. Um, and say, you know what, we've learned a whole bunch on this project. So maybe right now it is time for us to stretch our legs a little bit further and figure out if we can learn monogame. Sorry, Godot. uh, and my initial thought was to just get used to how an engine like that. Yeah, to see how such an engine would work and how you do such things like making a game. Um, we're gonna make literally this dodge the creeps, but we're gonna call it dodge the minions, and then at some point we might even do a bit of acid flip and what have you. Yeah, why not? Right? Because we're gonna learn now about basically how Godot works, how to deal with all that. I think I have the assets already downloaded, by the way, so we're just gonna go through step by step and see where we get to. Let me. Okay. I forgot something. Where is? Give me a minute. Let me go and put you somewhere. It's back. I do apologize. Stop. No, enough. Just stop. Come on. You will stop. Mom's allowed to be at the door. Stop. Might have to call it. Yeah, I haven't got the assets right here. I can easily download them, but no. Right, I'm gonna have to call it. Let me try and quickly find someone to read out to. I do apologize, but it is what it is. Life happens, and then yeah. I can't even see anyone to read out to. Guys, no, I'm gonna have to call it. I will see you all tomorrow. I do apologize for the early finish. We'll jump into Godot tomorrow and see how that goes.